So today's lab is about the stereochemistry. Stereochemistry this is not included in your manual, so there's a handout for this, and the instructor will distribute handout for you. Stereochemistry has to do with the stereoisomers. So in order to understand stereochemistry, we have to understand the kinds of isomers. Isomers are compounds that two or more than two compounds that have the same molecular formula but different structural formula. Okay, for example, let's see, this is an ether. This is an oxygen atom attached to two methyl groups, right? So this one would be this is a dimethyl ether. And the molecular formula is C2H6O. Now this is a dimethyl ether. This belongs to the ether group. This one is alcohol, OH group. It also has the same molecular formula, C2H6O. However, what's the difference between this and this? Because the connectivity is different. Here, oxygen is attached to two carbons. Here, oxygen is attached to hydrogen and carbon. Connectivity is different. Therefore, they are isomers, but they are such isomers that the connectivity is different. These are called constitutional isomers because the constitution is different. Okay. These are constitutional isomers. There's another kind of isomerism called stereoisomerism. So let's go ahead and discuss that. See, for example, these two molecules. Notice now, what's the difference between these two molecules, right? Many people would say there's no difference. There's no difference. Look at the connectivity. You know, red, black, yellow, white. Same thing. Same thing exactly here. So what's the difference between these two? Trust me, they are different molecules, okay? They are different molecules. Look at I'm basically orienting them in a way that they look like mirror images of each other, right? See, yellow versus yellow, red versus red, white versus white, black versus white. So there's a mirror right in the middle. There's a mirror images of each other. Now you try to superimpose them. You will not be able to superimpose them. See, white over white, black over black, but here they are not superimposable. So these are mirror images that are not superimposable. They are called enantiomers. So these are enantiomer. We call them plus enantiomer and minus enantiomer. The reason is why plus and minus? Because these two compounds or molecules, they will have exactly the same physical properties like melting point, boiling point, NMR. All physical properties are exactly the same. There are two properties, however, that they are different. This will behave differently than this one. What are those two properties? You might be familiar with the phenomenon called plane polarized light. Ordinary light, when it passes through a calcite crystal, it becomes one plane. And so that light, if that light is passed through a solution of this molecule, it will rotate the plane towards either left or right. Suppose this one rotates the plane towards right, then this will rotate the planes towards left. So that's the difference between the two. Enantiomers differ because they rotate the plane of polarized light in opposite directions. Now there's other property that will differentiate these two, and that is their behavior in other chiral environment. Let's say another chiral environment here, and then this molecule will be different, will behave differently than this molecule. Now I have used the term chiral molecule. What does a chiral molecule mean? For that, I'm talking about an atom like here, which is attached to four different groups. So this is a special atom which is attached to four different groups: black, white, red, and yellow, different groups. So this atom is called asymmetric carbon. Some people call it chiral carbon. Some people call it asymmetric carbon. Some people call it stereogenic center. You know, there are some, subtle differences between those terms, but, for your class, These are all synonymous terms: stereogenic center, stereo center, asymmetric carbon. Same thing, right? Meaning they are attached to 4 different groups. This is a tetrahedral carbon, sp3 hybridized, right? Now this one and this one is also chiral or asymmetric carbon. However, one is plus and the other is minus, depending upon how they rotate the plane of polarized light in opposite directions. Okay. Now, I want to actually talk about planes, elements of symmetry. There are basically 2 elements of symmetry that you need to understand for this course: plane of symmetry and center of symmetry. This molecule does not have any element of symmetry, no matter what, okay? Because there's no symmetry at all, okay? You cannot divide it into 2 parts or something like that. The same thing with this enantiomer. However, think about this now. This molecule, I can rotate the plane of polarized light, okay, like this. I'm changing the conformation. By rotation of the bond, I'm changing the conformation, not configuration. For configurational change, I will have to break 2 bonds, right? For example, here, if I want to change this into this, right, then I will definitely have to interchange these 2 groups. Break bond, this bond, I can break it. And this also I can break it. And I can switch it. I switch it now. Now I have changed the configuration. Now these 2 molecules are identical. Okay, they're identical. Look at that. Why I call it identical? Because they are superimposable. They are not, first of all, they are not mirror images, and they are superimposable. Black over black, yellow over yellow, red over red, white over white. So this is completely superimposable. They are the same molecule. Same molecule, they are the same enantiomer. Both plus or both minus, okay? Some people call it homochiral. These are homochiral, and the other one, non-superimposable mirror images. If I can do that again, actually I can change it back to this, change it back to mirror images now, right? These are mirror images, and they will be mirror images, therefore they will be non-superimposable mirror images or enantiomers. Okay. All right, so these 2 are heterochiral. Heterochiral means enantiomers. Okay, now you may not be familiar with heterochiral, but just consider them. They are different enantiomers, plus and minus. Okay. Now, about the elements of symmetry here, I rotate I'm changing the conformation here. Now look here, I can actually cut the molecule through the middle into 2 halves. This one will be the mirror image of the other half. So this this molecule or this conformation has a plane of symmetry. So half of the molecule is the mirror image of the other half. This compound or this molecule will be called a meso compound. Meso means that one half of the molecule is the mirror image of the other half. And these molecules are not chiral, even though they have chiral carbons, but the overall chirality is neutralized. Okay, so it's not chiral. They do not rotate the plane of polarized light. Okay, so so this has a plane of symmetry. Now this has only one plane of symmetry out of millions of them. See this one, for example, right? There's not a plane of symmetry. You can go around and make millions of them. There's only one plane that is has a plane of symmetry, and that will make it achiral or non-chiral. It will not be an optical isomer. Okay. Now, does the molecule have a center of symmetry? The other element, there are two elements of symmetry, plane and center. Center of symmetry, I rotate this molecule, change the conformation, and watch here now, these yellow atoms, if I join them together with a line, it will pass through the bond, the center of the bond. Similarly here, through the center of the bond, white to white and black to black. The whole molecule will be reflected through a single point right in the middle of the bond. So we say that this molecule has a center of symmetry. So the molecule that has a center of symmetry is also called meso. The molecule that has a plane of symmetry is also called meso. Okay, so meso compounds are not chiral. Overall chirality is not there. So this molecule is not chiral. Okay. Now, what happens if I change the configuration by breaking two bonds? So I'm breaking this bond, right?
So today's lab is stereochemistry.
Stereochemistry. This is not included in your manual, so there's a handout for this, and the instructor will distribute handout. All right. So here for you.
Stereochemistry has
this molecule does not have any plane of symmetry.
So in order to understand stereochemistry,
this is the mirror image of that, but this is not the mirror image.
Isomers are compounds,
not the mirror image of that. This has no plane of symmetry.
What about compounds that have the same molecular formula?
Well, I think
structural formula.
Look at that. Okay, for example, to the center.
See,
this is okay.
But
so
what about
this
atom
one
attached to two methyl groups?
Right?
So this one
black is going through the center and meeting white.
And this
That's not right.
molecular formula
So
is
this molecule
C2
is not meso.
Oh,
this is one of the
this is a
enantiomer pair.
ether. This
is a heterochiral
This
molecule,
one,
right? It will have a
alcohol,
mirror image
OH group,
and that will be
it also has the same molecular formula C2
that's
H6O.
plus O will be minus.
However,
So just by interchanging
the connectivity is basically changing the
Here
configuration.
oxygen is attached
Now,
to two carbons.
What's
Here
the difference
oxygen
between
is attached
this
to
molecule
hydrogen
and carbon?
and the one that I
Connectivity is
showed you,
different.
meso.
Therefore,
Now
the
meso was
isomers,
not
but they
chiral.
are
This one is
such
chiral.
isomers that the connectivity
So
is
they are
different.
not enantiomers.
These are called
So
constitutional.
what are those?
isomers.
What's the
The
relationship
constitution
between
is different.
the one that had center of
These are
symmetry and
constitutional
plane
isomers.
symmetry?
There's another
And then-
kind of
and isomerism, they are
called stereoisomerism.
So by
So
definition,
let's, go ahead and
Dias-
ask us that.
diastereomers are
stereoisomers that
these
are
two
not
molecules.
images.
Notice now this will.
What's the difference between these two molecules, right?
Many people would say there's no difference.
Now these are
There's no difference. Look at the connectivity.
Diastereomers,
Red, black, yellow, white. The molecule may not have any chiral center. So what's the difference between
Look at
these
this
two?
one.
These are the
Trust
double
me,
bond.
they are different
So this is
molecules.
sp2 hybridized.
They are different
carbon.
molecules.
sp2 hybridized carbon has a plane of symmetry. I'm basically orienting them in a way that they look like.
This is not a chiral carbon. It's not a chiral carbon. For chiral carbon,
Yellow versus yellow.
you need to have four different groups.
Okay. So there's a mirror right in the middle.
What about this one?
Mirror
In this
image.
here,
When
you try to superimpose
red
them
ones on the same
you
side,
will not be able to
green
superimpose
ones
them.
on
See,
the same
white
side.
over white.
So we call
Black
that
over
cis
black.
molecule.
But here, they are
A
not
Z
superimposable.
molecule.
So these are mirror images that are not superimposable. They are called enantiomers.
And green,
These are enantiomer.
I
We
cannot
call the
break
plus
because
enantiomer
the double bond cannot
and
be
minus
broken.
enantiomer.
So this is permanent.
The reason is
configuration.
why plus
If
and
I want
minus
to change
this
this configuration to
these
that, I have to break the bond.
two
To break
compounds
this bond
or
over here, that
molecules,
one over
they
here.
will have exactly the
To convert
same
this into that.
physical properties.
Now these are
melting
stereoisomers
point
because the
and
connectivity is the same. However, the orientation is
exactly
of
the
the
same.
groups that are attached to
There
it
are two
is
properties,
not the same.
however, that
So,
they are different.
these are not.
This will behave differently than this one.
See,
What
these are
are those two
stereoisomers
properties?
that are not.
You might be familiar with
Mirror images of
the
each other.
phenomenon called
That means these
plane
compounds
polarized light.
also
Ordinary light
frame
when passes through
the
a
definition
calcite
of
crystal,
stereoisomers.
it becomes
So
one
stereoisomers
plane. And
So
the compound
that
may
light
or
may
that
not
light
have
is passed
ions.
through a solution of
These two molecules do not
this
have.
molecule. It will rotate the plane
Uh,
towards either left
still
or
they
right.
are
Suppose this one rotates the
I
plane
hope
towards
that you
right.
get the idea
Then
described to you.
this will rotate
Enantiomers
towards
are
left.
enantiomers are homochiral.
The two
Enantiomers differ. Enantiomers they rotate and plane the polarized light, the other is minus. They rotate the plane. Now there's another property that's I have described to you differentiates with diastereomers, and that is their behavior in other chiral environment. And let's say another chiral environment here
and centrosymmetry.
Okay. And I have molecule will be different to explain to you. Behave differently. Molecules that are
Chiral.
Now I have used the term chiral molecule. What does a chiral molecule mean? Alright, so how do we describe these enantiomers? These are non-superimposable mirror images. The mirror images, but they are not superimposable, right? How do we describe this in terms of clarity? What kind of, I've said that minus and plus. Now minus and plus, they refer to the rotation of the plane polarized light. But and that is something about the rotation. But I'm talking about how can we describe this carbon differently than this carbon, okay? So there's a convention that came out in the 60s. It's called Kohn-Ingold Prelog convention. And that convention describes the chirality of the chiral center, which are different with 4 different groups in terms of R and S. R rectus, S sinister, right? So, for example, let's discuss this in enantiomer, for example. Now, this is a small ball here. I would just call it hydrogen. Hydrogen has the atomic number 1. Now, the other 3 are chlorine, bromine, and fluorine. Now, in the periodic chart, bromine is number 1 because its atomic number is 37, and chlorine, atomic number 17, and fluorine, atomic number 9. So that means that if I keep this lowest priority away from me, then I have a steering in which I have to prioritize bromine and chlorine and fluorine. So highest is bromine, middle one is chlorine, and lowest here in these 3, lowest is fluorine. Okay, so I move my car towards, if this is the steering, I'm moving my car towards left. So that means that the molecule has S configuration, sinister S configuration. Now if I go to the other enantiomer, which is that, I could actually convert this into its enantiomer by changing the configuration. I could do that. Okay, let's change it. I can do this, like I can interchange any 2. Now I have converted one enantiomer to the other enantiomer, right? So what was do you remember? That was S configuration. Now this will be R. It should be R. How? I change. I hold the molecule in such a way that the lowest priority is away from me. Okay, and now I'm assigning a priority. This is bromine. This is chlorine. This is fluorine. Right? So this is number 1, this is number 2, this is number 3 in terms of atomic numbers. So I'm moving my car towards right. Okay, from my perspective, I'm moving the car towards right. Therefore, the configuration of this chiral center is R. Okay, now what happens? See this molecule, this carbon is not chiral. It's not asymmetric because there are 2 identical groups. For chirality or asymmetry, all the groups should be different. These are 2 same. Okay, so that's not chiral. How about this carbon? This has this group, and this group. This is oxygen, this group, and the whole ethyl group. So this is definitely chiral carbon, the middle one that I'm holding. This is achiral, means non-chiral. This is chiral. This one is also achiral because there are 2 identical groups, and this of course is achiral as well. So in this entire molecule, there is only 1 carbon atom that is asymmetric. So we have to focus on that. So how to assign R and S configuration? So I keep the lowest away, because that's the rule. Keep, you have to orient the molecule in a way that the lowest priority is away from you. Now this is number 1. Now I have to decide, this is carbon, this is carbon, both of them they are 6. So how do I decide then? I know this is number 1, but what about number 2? Well, you can decide it because these two carbon atoms are not exactly the same, because their links are different. This is linked with the methyl group, and this carbon is linked with an oxygen. So remember, the atomic number of oxygen is 8. So you cannot compete with this. This is definitely number 2 carbon. Okay. So you say 1, this is 2, this is 3. Okay. So I'm moving my car towards left. So this particular configuration is S configuration. And the other would be, if I interchange any 2, right, and interchange any 2, that would be, I would be changing the configuration. I'll be changing one enantiomer to the other enantiomer. And now again, keep the lowest priority away from me. Now this is 1, this is number 2, this is number 3, this is R. Okay, I hope you can understand the RNS configuration.